All right, welcome to today's Explainer, where we're going to clear the fog a bit. If you've been anywhere near the internet, the news, or even just talking with coworkers lately, you've probably been hit by an absolute barrage of AI jargon. Words like LLMs, RAG, agents, and neural networks are just thrown around constantly. And honestly, it can feel completely overwhelming to try and piece it all together. So together, we're going to build a highly navigable map of the entire artificial intelligence landscape, so we can finally see exactly how all these moving parts connect.
Here's our itinerary for today's journey. We'll start off by defining artificial intelligence, move into the core engines of AI, explore building and implementing AI, look at the rise of AI agents, and finally, wrap up with ethics, safety, and tomorrow. Let's jump right in.
Section 1. Defining artificial intelligence, mapping the territory.
At its core, artificial intelligence is really just machines simulating human intelligence processes, acquiring information, reasoning to reach conclusions, self-correcting. But Hollywood drastically skews our perception of this. They almost always depict general AI, or AGI, which is a purely hypothetical system with human-level cognitive ability across literally any domain. Some sci-fi goes even further to superintelligent systems, but in reality, what we actually use every single day is called narrow AI. Think about your spam filters, your Netflix recommendations, or voice assistants like Siri. They are highly specialized, designed to perform one specific task, and they simply cannot generalize beyond their program domain.
To truly understand where we're at right now, we can categorize AI functionality into 4 distinct types. Historically, we started with reactive machines. Think of IBM's Deep Blue chess engine. It had absolutely no memory, reacting purely to the board state right in front of it. Today, we exist almost entirely in Category 2, limited memory. This is where most modern AI, including massive language models and self-driving cars, sits. They use past data to inform present decisions. Now, as for theory of mind, which would actually understand human emotions and beliefs, imagine if your car knew you were having a terrible day and automatically adjusted the driving mode to be smoother. Yeah, we aren't there yet. And self-aware AI, that remains strictly theoretical.
Section 2. The core engines of AI, how it learns.
So, how do these engines actually learn to do what they do? There's a major historical shift we need to talk about here. On one side, you have symbolic AI, sometimes called classical AI. It relies on explicit, human-programmed if-then rules. It's kind of like giving a computer a highly rigid baking recipe. It's incredibly reliable, but it is deeply brittle when faced with the messy, unstructured reality of our world. On the other side is machine learning. Instead of giving it a rigid recipe, we just feed the system thousands of different cakes, and the system learns to identify the patterns of a good cake completely by itself, without being explicitly programmed. That one conceptual shift completely solved the brittleness problem and changed everything.
Zooming in a bit further, we find deep learning. Deep learning is basically just a highly advanced subset of machine learning. It utilizes multi-layered artificial neural networks, loosely inspired by the structure of the human brain. By adjusting the mathematical weights of connections between these artificial neurons using massive amounts of data, these deep networks can learn incredibly complex hierarchical representations. That simply means it learns to recognize raw edges, then combines those to recognize shapes, and then combines those to recognize entire faces. This layered learning is exactly what makes modern image recognition and natural language processing possible.
Then, in 2017, the AI world experienced an absolute earthquake. Google published a research paper famously titled, "Attention is all you need." This paper introduced the transformer architecture. Before this, processing human language was pretty slow and clunky. Transformers use this brilliant mechanism called self-attention to instantly relate every single word in a sequence to every other word, figuring out context with unprecedented accuracy. And ironically, this exact architecture from Google became the bedrock foundation powering OpenAI's ChatGPT and the massive language models we all rely on today.
Section 3. Building and implementing AI, the tool belt.
To understand how we actually implement this stuff, consider that a raw, freshly trained AI model is a bit like a highly knowledgeable but incredibly chaotic toddler. It just blurts things out unpredictably. The magic ingredient that turns it into a polite, conversational assistant is RLHF, or Reinforcement Learning from Human Feedback. Human testers rank the AI's varied responses, and the model is then fine-tuned to maximize a reward based on what humans actually prefer. It's what aligns these raw predictive models to be genuinely helpful, coherent, and safe for us to interact with.
But this brings up a massive real-world challenge. Ask a newly trained AI who won a sports game yesterday, and it might confidently fabricate an entirely wrong answer, a hallucination. Because its knowledge is completely frozen in time at its exact training cutoff date, we desperately need a way to give it access to the dynamic outside world. And we need to do it without spending millions of dollars retraining it every single day.
Well, it turns out there's a brilliant solution for this called RAG, or Retrieval Augmented Generation. Think of it as suddenly giving the AI an open book test. First, your question is converted into a mathematical vector. Second, the system searches a vast database for the most semantically similar documents. Third, it retrieves that specific, factual context and injects it right into the AI's prompt. Finally, the AI generates a response strictly grounded in that freshly retrieved content. It dynamically solves the knowledge cutoff problem instantly.
Section 4. The Rise of AI Agents, from Stateless to Autonomous.
Up to this point, we've essentially looked at AI as a highly advanced answering machine. But there's this stark contrast emerging, and it absolutely defines the future of the field. Traditional, non-agentic AI is like a calculator. It's single-turn, stateless, and entirely dependent on you giving it a prompt. Agentic AI, however, is goal-directed. It's much more like an autonomous personal assistant. It can maintain memory across interactions, break complex goals into multi-step plans, and actually use external tools, like browsing the web or querying databases, to get a job done completely on its own.
The core architecture making this possible is beautifully encapsulated in frameworks like ReACT, which stands for Reason plus Act. It outlines how an agent operates in a continuous loop. It perceives your goal, it thinks about what action to take next using a language model, it acts by calling a tool or running code, it observes the direct result of that action, and, here's the crazy part, it repeats. It dynamically adjusts its own plan on the fly, interleaving reasoning and action over and over again until the objective is entirely achieved.
And what makes these agents so incredibly capable is that they're powered by generative AI spanning multiple modalities. They aren't restricted to just reading and writing text anymore. These systems can generate entirely new text, create stunning images using diffusion models, generate hyper-realistic video, synthesize completely new audio, and even write complex code. This multimodal capability to perceive and create across all these different domains makes these autonomous systems vastly more versatile than anything we've ever built before.
Section 5. Ethics, Safety, and Tomorrow. The Horizon.
As we look to the horizon, the absolute core concept we face is alignment. It's essentially the modern version of the King Midas story. We have to ensure these incredibly powerful systems pursue goals that are genuinely beneficial to humans. The profound danger here is that a misaligned AI might optimize for a proxy metric we didn't intend. It could cause massive harm while technically following the exact rules it was given, simply because it lacks basic human common sense and our shared values.
Beyond alignment, researchers are fighting some massive, immediate fires today. Because AI learns directly from vast troves of human data, it actively inherits our biases. It's a technical reality we're battling constantly to ensure fairness. We're also working to build robustness against adversarial attacks designed specifically to trick the models, secure data privacy, and navigate rapidly emerging frameworks like the EU AI Act, which aims to categorize and regulate the riskiest of these systems.
Okay, let's take a collective breath. Looking at the complete map we've drawn today, you can really start to see how all the pieces of the puzzle fit together. We navigated from broad capability tiers like AGI, down to architectures like deep learning, implementation patterns like RAG, training techniques like RLHF, and all the way up to autonomous agentic AI. This right here is your foundation.
I want to leave you with a provocative thought. We are witnessing a monumental shift in real time. As AI transitions from answering our questions to autonomously acting on our behalf out in the wild, how will we ensure its goals remain fully aligned with our own? Deeply understanding the map we just built is the very first necessary step to finding out. Thanks for joining me on this explainer, and keep exploring.